Welcome to this session. In this session, we are going to discuss about simplest protocol, stop and wait protocol and stop and wait ARQ. In the data link layer concern, it provides all services through protocols only, and the services delivered exactly to the receiver will be ensured by means of acknowledgement. As I said, protocols plays major role in the service provisioning, so that the protocol is implemented in the form of software. There are two different channels already we have discussed, noiseless channel and noisy channel. In the noiseless channel, simplest protocol and stop and wait protocol is defined. For noisy channel, stop and wait ARQ, go back and ARQ and selective repeat will be executed in the noisy channel concern. First one, noiseless channel. There are two protocols defined here, simplest protocol and stop and wait protocol. First we will see some characteristics of noiseless channel. The noiseless channels are ideal channel. It is theoretically implemented, not practically. So that some assumption made in the noiseless channel in order to implement error control. Here no error control procedure available in this channel. So that we made some assumption regarding this channel. What is it? No data loss incurred in the transmission. No data loss is occurred in the transmission and data is not corrupted. And also no duplicate packet or duplicate acknowledgement available here. And one more point is no flow control procedures exist in the first noiseless channel. First noiseless channel protocol, simplest protocol. See, as I told previously, simplest protocol and stop and wait protocol is defined in the noiseless channel. First we will see simplest protocol. In the simplest protocol, no error control and no flow control. Because as we have in the assumption, as we have some assumption about the error control, so that no error control procedures available in the channel as well as in the protocol. And then additionally in simplest protocol, no flow control. No flow control procedure means we have to do certain assumptions. What is it? No flow control means the flow will not be regulated between sender and receiver. So that once the data is received by the receiver, immediately that data have to be processed. See here, once the frame is received by the physical layer at receiver, immediately it has been given to the data link layer, and the data link layer extract the data and deliver the data to network layer. This what happening at receiver because of this reason. This particular receiving frame by physical layer and data is extracted by the data link layer and delivered to the network layer. This process takes very minimal time, even in 1 or 2 milliseconds. This particular assumption is defined in the simplest protocol. Then only the overwhelming situation will not be occurred at receiver. Overwhelming situation will not be occurred at receiver. What is meant by overwhelming situation? Due to some reason, the receiver is not able to receive the data as in the original speed. That situation is called overwhelming. This particular overwhelming situation entirely avoided in simplest protocol because of this assumption. And then the diagram shows you the simple designing elements or components of simplest protocol. We are taking two different components, sender and receiver. Come to sender side, left hand side. There are 3 layers involved in the communication, as we know, because data link layer is available in between network layer and physical layer, so that we are going to discuss 3 layers here, network, data link and physical layer. Once the sender is having data to send, then immediately it send notification to data link layer. Data link layer receives that notification, then execute the corresponding procedure to read the data from the network layer, and then after reading the data, the frame is constructed by the data link layer. Constructed frame is transmitted through physical layer over the medium. The physical layer receives the frame constructed by the data link layer and forward the data frames through physical medium. Come to the receiver side. The receiver side, as I told earlier, there are three layers available: network layer, data link layer and the physical layer. The physical layer at receiver receives the frame, transmitted frame. Then immediately it sends notification to data link layer about the incoming frame. Data link layer receives this notification. Immediately it extracts the data from the frame, and then the extracted data is delivered to the network layer, and it does not have any acknowledgement scheme, no flow control, no acknowledgement scheme implemented here, so that nothing is transmitted from the receiver to sender. And then data link layer at sender is waiting for the next event notification. Come to the bottom side diagram. Come to the bottom side diagram. Here the event is exist. What is the event? Request from network layer. Request from network layer. As I said previously, the data link layer receives notification about request to send from network layer. That event is happened here. If such event is happening, immediately the data link layer execute the algorithm which is available in the data link layer. This algorithm is available in repeat forever form. It means continuously it is waiting for the event. If any event is occurred, immediately that algorithm is executed and it does the work. Come to the right hand side, bottom side. The diagram which is available here at receiver, similar like sender, the event is occurred at receiver. What is the event? As I said previously, whenever the physical layer at receiver receives the data frame, immediately it sends a notification to data link layer about the incoming data. Immediately the algorithm at receiver side will be executed. This is also executed in the form of repeat forever. Continuously it is running and waiting for the event. If event occurred, then execute the algorithm and waiting for the event, and so on. Continuously it is running. That algorithm available at receiver will be executed. It extracts the data and data is given to the receiver. Next, I'll discuss the algorithm at sender in simplest protocol. As I said previously, here the while loop is defined here. It takes true condition always. In infinite loop it is continuously running and then waiting for the event. At sender, request to send event will be happening, so that it is waiting for the event. If the request to send event is occurred, immediately control enters here and it execute get data procedure to read the data from the network layer. And then after reading the data, the frame is constructed by executing make frame procedure, and then by using send frame procedure, the constructed frame is transmitted. See, come to the receiver side. Again, as I said previously, receiver side also we are having infinite loop. While loop, it takes true parameter. And next one, it is waiting for the event arrival notification. Frame arrival notification is the event. If any such event is occurred at receiver, immediately control enters here and it executes receive frame procedure, and receive frame procedures receive the frame and extract the data, and then the extracted data is delivered to the network layer by data link layer. This is the algorithm is executed at receiver. And then the flow diagram is explained in this slide. There are two entities available, there are two nodes available, sender node and receiver node. At sender node, request to send event is occurred. If such event is occurred, then frame is transmitted and it reaches the receiver. Once the frame reaches the receiver, immediately the arrival notification is transmitted to the data link layer at receiver. If it receives the arrival notification, this frame is processed and it is delivered to the network layer. and again it is waiting for, sender is waiting for the request. If such request is received, immediately the frame is transmitted. This particular procedure will be executed continuously. The next protocol is stop and wait protocol. What is the objective of this protocol? Already we have simplest protocol. It is very simple to implement. Why we are discussing about stop and wait protocol? Why we are discussing about stop and wait protocol? It means the simplest protocol does not have any flow control. Simplest protocol does not have any flow control. So that in order to achieve flow control, we are going from simplest protocol to stop and wait protocol. Because in the real situation, at receiver, there is a possibility of overwhelming situation. At some time, due to some reason, for example, overload at receiver, due to some reason, the receiver is not able to receive the data, as well as it does not have enough time to process the data. It does not have enough time to process the data. If such things happened at receiver, that situation is immediately notified to sender. Then sender reduces its sending speed. Then the flow will be matched, or flow will be controlled between sender and receiver. I'll explain the design components for stop and wait protocol here. In the stop and wait protocol, as I said previously, acknowledgement is available here. Acknowledgement is available here for each and every data frame transmitted from sender to receiver. Come to the sender side. As we have in the previous protocol, there are three layers available: network layer, data link layer, and physical layer. Because in between data link layer, in between network layer and physical layer, data link layer is available. So that we are discussing about these three layers. From network layer, request to send notification is transmitted whenever the sender is having data to send. Then data link layer receives that notification, then it extracts the data, it gets the data from the network layer, and then the frame is constructed. The constructed frame is transmitted to physical layer. The physical layer sends the data frame over the physical medium. Come to the receiver side. About data frame. The data frame is received by the receiver. Immediately the notification is given to the data link layer about the incoming data. If such notification received by the data link layer, then data link layer extract the data from the frame, and that data, extracted data, is delivered to the network layer. Once it is delivered successfully, then the frame, the acknowledgement frame is constructed by the data link layer. That acknowledgement frame is transmitted through physical layer over the medium. See here, acknowledgement frame is transmitted back to sender. Come to the sender side. The sender receives the acknowledgement frame. Immediately the physical layer send notification to data link layer about the incoming acknowledgement frame. Then data link layer receives that acknowledgement and concludes that the data is, or previous frame is, delivered successfully to the receiver. These are all the functions executed in the stop and wait protocol. Come to the notification diagram. At sender, there are two different events occurred. There are two different event notification raised at sender. If the sender wants to send data frame, then request to send event notification is issued from the network layer to data link layer. Once that request to send notification received by the data link layer, immediately it executes the algorithm available within the data link layer. Once the algorithm executed means the data is delivered to the receiver. And then when this second event will occur means whenever the sender receives acknowledgement frame. Whenever the physical layer receives acknowledgement frame from the receiver after delivering the data. Then the physical layer at sender send the notification to data link layer process the acknowledgement, come to the receiver side. At receiver side only one event is occurred. What is it? The event is nothing but receive frame event. The event is receive frame event. Whenever the receive frame event is received, then that notification is transferred to data link layer. And then in the data link layer at receiver, that algorithm will be executed and the data is delivered to the receiver. Receiving process. And then next we are going to discuss about the algorithm at sender in stop and wait protocol. As we have discussed earlier, it is an infinite loop. Continuously we are running, or continuously the algorithm is running, so that while true, and then additionally we need this variable. Because stop and wait. After transmitting one frame, it is waiting for the acknowledgement. No data transmission during the waiting time. It is waiting for the acknowledgement from the receiver. Once the acknowledgement is received successfully, then only the sender transmit next frame. In order to achieve this kind of operation in the stop and wait protocol, we are setting can true variable is true. Whenever this variable is true, then only we are able to send data. And then next one is sender is waiting for the event. Data link layer at sender is waiting for the event. What is the event here at sender? Request to send. The event name is request to send. It is issued by the network layer at sender. That event have to be checked whether any such event is received by the data link layer. Checked here, and then we are having uncondition. When we are allowing the system to transfer data, if can send is true, then only we are allowing the system or allowing the sender to send data. So both the condition will be checked. Both the condition is true, then control enters here. It executes get data procedure. Get data procedure reads the data from the network layer. After reading the data from the network layer, it constructs the frame. By using make frame procedure. After constructing the frame by using send frame procedure, the data frame is delivered to the subsequent layers and through medium. And also it is waiting for the event because the transmission is over. It is waiting for the acknowledgement. Sender is waiting for the acknowledgement. If any such acknowledgement is occurred, so we are waiting for the event. Wait for event. Whenever that event happens, it means it receives any acknowledgement from the receiver. Then this particular event is raised. Then arrival notification is issued by the physical layer to data link layer at sender. Immediately control enters here and it executes receive frame procedure. Then it receives the frame. And acknowledgement frame. No data involved in that. It is some kind of acknowledgement or some kind of receiving data, right? Some kind of acknowledgement for receiving the data. And then immediately the can send variable is true. Once this is set to true, then only we are able to transmit the next frame once that event is occurred. So acknowledgement is defined here in the stop and wait protocol, so that flow control procedures exist. So it is waiting for the acknowledgement. If acknowledgement is received, then the next frame will be transmitted. Next one, the algorithm which is executed at receiver in data link layer. And then as we have discussed earlier, this is also infinite loop while true, right? While true. And then it is waiting for the event. What is the event here? The event is receiving frame notification or frame arrival notification. If any such arrival notification issued by the physical layer at receiver, then control enters here. The data link layer at receiver receives the frame and extract the data from the frame by executing extract data procedure, and then the extracted data is delivered to the network layer by using deliver data, and then again we are having send frame. This is not a data frame. After receiving the data frame correctly, the receiver send acknowledgement frame. So again it calls send frame procedure to send acknowledgement to the sender. This is happening at receiver. This algorithm will be executed at receiver in stop and wait protocol concern. In the flow diagram of stop and wait protocol is, there are two entities available here, sender and receiver, A and B. Whenever the request is received, what is the request? Request to send. A request to send notification or a request to send event is occurred, immediately the frame is transmitted from A to B. Once it is arrived at receiver, immediately the arrival notification is given to DLL in receiver side. If arrival notification is received, that data frame is extracted and the data is delivered to the network layer. After delivering the data successfully, the acknowledgement frame is constructed and acknowledgement frame is transmitted to sender. Once the acknowledgement frame reaches the sender, immediately arrival notification about the acknowledgement is issued by the physical layer at sender. Then immediately, if that arrival notification is received, it receives the acknowledgement and concludes that the previous frame is transmitted successfully. Then it is waiting for the request. If request is received, then it transfers the next frame and so on. By this way, the entire system is working according to stop and wait protocol. Here we are having flow control. These two protocols defined for noiseless channel. Next, we are going to discuss the noisy channel protocols. In that, first we will discuss stop and wait ARQ. What is meant by ARQ? Automatic repeat request. This particular concept already we have discussed in the flow control. Whenever the sender and receiver is not able to send the data or receive the data as in the original speed, then there will be a flow mismatch. Occurred. If any flow mismatch occurred, then there is a possibility of data loss. In order to avoid that data loss, immediately the flow control procedures are activated. That will be executed and regulate the flow. How it will be regulated? By means of, suppose the receiver is not able to receive the data as in the original speed, then it means overwhelming occurred at receiver. Immediately it will be notified to the sender. Sender regulates or reduces its transmission speed or reduces its data rate until the problem is rectified at receiver. Once the problem is rectified at receiver, immediately that parameter reset to original data rate. Right? And then there are four parameters or attributes we are going to discuss in stop and wait ARQ. Right? The parameters are sequence number, control variables and timers, and acknowledgement operations. Why we are discussing this kind of parameters or attributes in stop and wait ARQ than stop and wait protocol? You just recall the stop and wait protocol. In stop and wait protocol, the flow control procedure is exist, but no sequence number. We are not following any sequence number in the stop and wait protocol because no error control in noiseless channel, and also stop and wait protocol, no error control, so that the sequence number for each and every frame is not required, but here in the noisy channel, we know that noisy channel concern, this is the practical channel, there will be a data loss. There will be a data loss in the noisy channel. Whenever we are receiving data, some of the bits available in the data may be corrupted in the noisy channel. Sometimes we are not able to receive the data properly. Sometimes we are able to read or receive duplicate frame. It means duplicate acknowledgement or duplicate data frame. Any possibility of duplicate frame may be received in the noisy channel. Because of these reasons, the error control procedures implemented here, in order to achieve that error control procedure and flow control procedure, we are using sequence number for each and every frame. Each and every frame. For example, in the previous case, I mean stop and wait protocol concern, if any data is lost, this will not occur. This will not occur because we are using noiseless channel, so no data loss, so that the error control procedure is not required. Is not required. So if that frame is transmitted, it received correctly. Only flow control is concerned in that stop and wait protocol, but no error control according to the noiseless channel specification. Here, stop and wait ARQ is defined in the noisy channel. In noisy channel, there will be a data loss possibility. If any data loss occurred, I mean data is lost or data is duplicated or data is corrupted, then we need to handle that situation. We need to control the error. In order to control the error, the ARQ mechanism is included in stop and wait protocol. What is meant by ARQ, automatic repeat request? It means if any error is occurred, then the receiver is not sending any acknowledgement. Simply the receiver kept in a silent mode. Kept in a silent mode. If such silence exists at the receiver, immediately the sender identifies that there will be some problem at receiver, because within the stipulated time period, within the timer time, it has to receive the acknowledgement. If it is not receiving acknowledgement, immediately the sender makes some conclusion about the previous frame. It does not deliver to the receiver. It has to be retransmitted. So that if any error occurred at receiver, immediately the automatic repeat request procedures executed, error control procedures are executed, then the previous request repeated automatically. Previous request repeated automatically. That's why we are using stop and wait ARQ in noisy channel. And then sequence number, control variable and timer, acknowledgement, operation. Why we are discussing these 4 parameters? The meaning is no error control procedures in the previous case. Now we required error control procedures because we are using noisy channel now. First I will explain the sequence number. Each and every frame is named with some number, 0, 1, 2, 3 and so on, right? Whenever we are giving sequence number, what is our motto? Means we have to reduce the sequence number range. We have to reduce the sequence number range. So that here, what is our working principle in stop and wait means transmit one frame and waiting for the acknowledgement. Once the sender receives the acknowledgement properly or positive acknowledgement is received by the sender, then only it transmits the next frame. So that in this case, we don't require too many sequence number. Frame 0. Frame 0 is transmitted. It is waiting for the acknowledgement. And then it transmits frame 1 and waiting for the acknowledgement. After receiving the acknowledgement, the same sequence number will be repeated cyclically, right? This same sequence number 0 and 1 will be repeated again and again. Same sequence number will be repeated again and again 010101. So in this case, in the stop and wait case, we are reducing the sequence number. We are using only the sequence number 0 and 1. The next one is control variable. Control variable. 1 second, I'll show one diagram for control variable. See here, there are two control variables available here, S and R. S control variable is available at sender. R control variable is available at receiver. What is the purpose of the variable S at sender? The variable S is used to keep track of sending frame. Keep track of sending frame. Which frame is transmitted, and it is waiting for the acknowledgement for which frame, and so on. In order to keep track the sending frame, S variable is maintained at sender, and then R variable is available at receiver. The reason is it is waiting for the data frame. Once the data frame is received correctly, how it checks whether the data frame which is required is received. 0 is expected, right? 0th frame is expected, frame 0 is received. In order to track the data frame and sending the acknowledgement for the successfully received frame. Sending acknowledgement for the successfully received frame, the variable R is maintained at the receiver. There are two control variables available here. There are two control variables available in stop and wait ARQ, and then timer. After transmitting each and every frame, the sender starts a timer. See here, after transmitting each and every, the timer is started at sender. Once the acknowledgement is received properly for the successfully transmitted frame, then it's sending, right? Then it is sending the next frame. The sender transmitting next frame. See, this is the timer, right? This is the timer. For each and every frame transmitted at sender, sender starts a timer before timer expires. Let us say the timer is set with some arbitrary value, 60, let us say 60, right? Timer is set with 60, 59, 58, 57 and so on. It has been reduced gradually. Once it reaches 0, the timer is expired. Before timer expire, the sender is expecting to receive the acknowledgement. If it is not receiving the acknowledgement before timeout occurred, then the current frame or previous transmission will be repeated. Suppose before timeout occurred, it receives the acknowledgement, then it transmits the next frame. In order to keep track whether the frame is successfully transmitted or not, we are executing or we are starting the timer at sender. And then next one is acknowledgement. In order to keep track the successfully transmitted frame, acknowledgement scheme is introduced here. The same scheme already available in the stop and wait protocol, but it does not have any number. Here the sequence number maintained for the acknowledgement. What is the reason for this acknowledgement? Means after sending each and every frame, the sender is expecting the acknowledgement from the receiver. Once the frame is successfully transmitted without any error, then acknowledgement is transmitted from the receiver to sender. Once the acknowledgement is received, it concludes that the frame is transmitted successfully, so that the sender transmitting next frame. And then there are 4 different operations defined in the stop and wait ARQ. What are all the operations defined here? In first one, normal operations. Next one, if the frame is lost, how the system behaves. And next one, the frame is successfully transmitted. While the acknowledgement is transmitted, it may be lost. Lost acknowledgement is the third scenario. And fourth one, due to some traffic nature or due to some traffic characteristics, sometimes delayed acknowledgement will be received by the sender. After the timeout occurred, it may receive the positive acknowledgement from the previously transmitted frame. Then what happens? How the system is behaving in that case, those things comes under operations of stop and wait ARQ. Right? You should remember there are 4 parameters or constraints available in the stop and wait ARQ concern. Number 1, sequence number. In order to keep track the sending frame, we are using sequence number. The sequence number starts from 0 and we are using only two sequence numbers 0 and 1. The same 2 sequence number repeatedly used. The reason is after sending one frame, we are waiting for the acknowledgement. Once the acknowledgement is received, then only we are going for the transmission of next frame. So that only 2 frame is enough. And then control variable, in order to keep track the sending frame as well as acknowledgement frame, the control variables are maintained at sender S and receiver means R. Next one, timer. Before timer expired, the sender have to receive acknowledgement, because within the stipulated time period, sender have to receive the acknowledgement. How it keep track that particular operation? By means of timer. After sending each and every frame, it starts the timer. Before timeout occurred at sender, it has to receive the acknowledgement. Next one, acknowledgement. This is used to convey about the previous successful transmission. Used to convey the message like previous transmission is successful, it is waiting for the next frame. That kind of concurrence is given to the sender. See, if the receiver receives the data frame successfully, then it sends positive acknowledgement. If it suppose the receiver is not receiving the packet or receiving the frame without any error, I mean it receives the data with the error, then simply receiver is kept in silent mode, no acknowledgement is passed to sender. If no acknowledgement means automatically the timeout will occur at sender. If timeout occurred, it repeat the previous transmission again. This kind of operations ensures the reliable communication between sender and receiver. There are 4 operations we will discuss later in this. And then next one, the components of stop and wait ARQ. Components of stop and wait ARQ. As I told previously, here we are using 0101 sequence number. 0101 sequence number. The SN, right? SN indicates current frame. SN indicates current frame. It is transmitted. It is transmitted, let us assume, and waiting for the acknowledgement. What happens at sender side? I will explain now. At sender, the request to send notification is given to data link layer by network layer. Immediately data link layer gets the data from the network layer and it constructs the frame. The frame is transmitted through physical layer and transmitted over the physical medium, and it is received by the receiver. It receives the frame and arrival notification is passed to data link layer from the physical layer. Once the arrival notification is received, then data is extracted and it is delivered to the network layer. Then immediately it sends the acknowledgement frame, and acknowledgement frame is also received by the sender. Here there are 3 different events is occurred. In the stop and wait ARQ means there are 3 different events is occurred. One is a notification about the data frame, and next one is notification about data to send. This is notification about the acknowledgement. This is timeout notification. There are 3 notifications executed at sender. Whenever the data is transferred from network layer to data link layer, this notification is given. That algorithm will be executed at sender side. Immediately the data is extracted and transmitted. Whenever it receives acknowledgement, then arrival notification of acknowledgement transmitted to the data link layer at sender. Then that will be executed and receives the acknowledgement frame successfully. The timeout event is occurred whenever the timer expired. When it happens, it starts the timer, send the frame and expecting the acknowledgement. if the acknowledgement is not received within the stipulated time period, then timeout occurred, then notification is transferred to the algorithm. If such event happened, then it repeats the previous transmission again. Next one is the algorithm available at receiver, event notification given about the data frame. If any data frame transmitted and it is received, then arrival notification is given to data link layer, and the data link layer receives that frame, and the frame is delivered to the network layer, and it transmits the acknowledgement. Next I will explain the algorithm at sender. What is happening at sender when we are executing stop and wait ARQ. The variable sn equal to 0, s suffix n, the variable sn equal to 0, can send is set to true, and infinite loop it is while conditions given here, wait for the event occurrence. If the event occurrence is request to send and can send is true, both the condition is true, then control enters here, it executes get data, and data is extracted from the network layer, and frame is constructed with the given frame number. That is very important. Make frame of sn here. Make frame procedure will be executed. It takes one parameter sequence number. By using that sequence number, it constructs the frame, and the frame is stored. Additional functionality defined here. Store frame of sn. What is the reason? Before sending data or before sending frame, the frame is stored in the buffer. What is the reason for this? If the frame is lost or the frame transmitted may contain error, may be corrupted. Because of that reason, sometimes the sender may have to resend the frame. In order to resend the frame, in the unsuccessful case, in order to resend the frame, that frame is stored in the buffer and transfer the frame. Suppose if it receives positive acknowledgement means, then simply it purge the stored frame. The frame is not necessarily be maintained in the buffer. It has been flushed. It is not required no longer. It is removed from the buffer. Suppose it is not receiving the positive acknowledgement, then the frame is taken from the buffer and again retransmitted. In order to retransmit the frame in the failure case, the frame is stored in the buffer and transmitted by using send frame. And then start this timer. I told that for each and every frame transmission, the timer is started, and then the sequence number is incremented by 1. In order to send the next frame, sequence number set to are incremented by 1, and then can send equal to false. It means after sending the frame, it is waiting for the acknowledgement, and also it starts a timer. It is waiting for the acknowledgement, so that before receiving acknowledgement, not possible to send data, so that can send equal to false, and waiting for the event. I told that there are 3 event is occurring at the sender, so that next one waiting for the event, and arrival notification. It means arrival notification for the acknowledgement frame. If any acknowledgement is arrived, then that notification is received. If any such notification is received, then receive frame, acknowledgement frame have to be received. Then receive frame will be executed and receive the acknowledgement. If the acknowledgement is not corrupted and it is equal to s of n, then stop timer. The sender receives the acknowledgement from receiver for the previous transmission, so that the timer is stopped. The stored buffer content is no longer needed, so that frame is purged from the buffer, and can send equal to true. Because we are receiving positive acknowledgement, we need to send one more frame. Then in order to cope up with the next transmission, we are setting the can send variable to true. And then third event at sender, timeout event. If timeout occurred, then that notification is given to data link layer, then it enters and starts the timer. It repeats the previous request, resend the frame. This is the algorithm is executed at sender, and perfectly the data is transmitted, and through stop and wait ARQ, the reliable transmission is achieved. And then next we will see the algorithm at receiver. Sn equal to 0. I mean frame number is set to 0, continuous loop, so while true, and waiting for the event. Come to the receiver side, only one event is occurring here, so that arrival notification, arrival of the data frame, that notification only transmitted here, so it is waiting for the event. If any such event occurred, then control enters here and it executes receive frame, it receives the frame and check for the error. The frame is checked for the error. If the frame is corrupted, then sleep. Then receiver get into the sleeping mode. It won't send any reply to the receiver. And then next one is, it checks the sequence number, whether it receives a acknowledgement number for the expecting one, or out of order acknowledgement number may be received. In order to check that, sequence number is compared with RN. If it is okay, then extract the data and deliver the data to the network layer, and the acknowledgement number is incremented. Send the acknowledgement frame. This is the algorithm executed at receiver in stop and wait ARQ concern. Next, we will see the operations that will be executed in the stop and wait ARQ. First one, normal operation. No error in the data transmission, no error in the acknowledgement transmission. Everything is going in a perfect way. Then what happens? Then how the system is behaving in that case will be explained now. As I said previously, there are two variables maintained, control variables S and R. What is the frame is currently transmitted, that frame number is set to 0. If S equal to 0 means we are transmitting frame 0, right? And then see, the R variable is written little ahead of that arrow. It means R equal to 0 means receiver is expecting 0th frame or frame 0. Receiver is expecting frame 0 is mentioned here, R equal to 0. And then the frame is received correctly without any corruption. Then it send acknowledgement. After issuing the acknowledgement, as we have discussed in the previous algorithm, after issuing the acknowledgement, immediately the R value is incremented. Next sequence number is assigned with R equal to 1. It means 0th frame received correctly, it is expecting frame 1. That acknowledgement is transferred here. Once the ACK1 received here, then the variable S is reset to next sequence number S equal to 1, because sender receiving positive acknowledgement, so that S equal to 1. What is the acknowledgement number? Same acknowledgement number is available in the S. S value is incremented by 1. Once the sender receives positive acknowledgement, then frame 1 is transmitted, and so on. In this way, the system behaves in the normal condition. Next, we will assume the second case. Suppose we are sending data, the data may be lost. Then what happens? How the system is behaving in that case? See, you can draw different diagrams. I am assuming that, right? Frame 1 is corrupted. Frame 1 is corrupted. Then I am having this diagram. Suppose if you are having the next occurrence of 1 may be corrupted, or first occurrence itself may be corrupted, then we can have different diagram in this scenario. First, understand the concept here. S equal to 0, the sender is going to transmit 0th frame, and receiver is also expecting 0th frame. Then frame 0 is transmitted. 0 equal to 0, the frame received correctly, send acknowledgement, R is incremented by 1. The acknowledgement is transmitted. Once the positive acknowledgement is received, then S variable is set to 1. The timer is started here. Why the timer is mentioned here? As I said previously, each and every frame transmission timer is started, but here it is indicated only in the failure situation, so that this particular place we are come across the failed situation, so that they are having some timer notification or timer identification. So S equal to 1. So frame 1 is transmitted. Unfortunately, the frame is lost. It is expecting the first frame, but the frame is lost. It is not receiving the frame. What happens? The frame is not received, then simply keep silence. Receiver is kept under silent mode. automatically the timeout will occur at sender. Sender retransmit the frame 1 again. Frame 1 is transmitted. Expected is 1. Received is 1. So properly it receives the frame and send the next acknowledgement. I told that 0, 1, 1 alternatively used, so that next one is acknowledgement 0, s equal to 0 and so on. By this way, the data frame is transmitted from sender to receiver and acknowledgement frame is transmitted from receiver to sender. And then come to the third case, frame is transmitted successfully, acknowledgement is also transmitted successfully. Unfortunately, the acknowledgement may be lost. If acknowledgement is lost, then what happened? We are going to see now. S equal to 0 and R equal to 0. Transmitted frame is 0, waiting frame is 0, so frame is transmitted successfully, acknowledgement is transmitted. S equal to 1. After receiving the positive acknowledgement, S is set to 1. Frame 1 is transmitted, R equal to 1, expecting frame is 1, frame 1 is transmitted and it is accepted by the receiver. It sent the next acknowledgement S equal to 0, but unfortunately this particular acknowledgement is lost here, so that here automatically the timeout occurred because before the stipulated time period it is not receiving the acknowledgement because the acknowledgement already lost, so that no acknowledgement, so timeout occurred. If any timeout occurred at sender, immediately the previous transmission will be repeated. Frame 1 is transmitted again. But see here, after receiving the frame 1 successfully, the R value is reset to 0. It is expecting the next frame. Expected frame is 0, arrived frame is 1. So frame is received in an out of order sequence. Expected frame is 0, received frame is 1. So we are receiving the frame in an out of order sequence. So that the frame is discarded. The receiver is concluding that there will be some problem in the previous acknowledgement, so that the acknowledgement is transmitted again. I mean, it repeat the previous acknowledgement. What is transmitted previously? ACK0, that will be repeated again. It is transmitted again, so that sender is successfully received the acknowledgement for the previous transmission and the next value is set and next frame is transmitted. It continues in the normal way. And next one is delayed acknowledgement. Sometimes the acknowledgement may be received by late due to traffic in between sender and receiver. Then how the system is behaving, we are going to see now. First frame is 0, expected frame is 0, frame 0 is transmitted, so successfully received, and acknowledgement is issued. After issuing the acknowledgement, R value is set to 1, and then the acknowledgement is transmitted. Here timeout occurred because due to some traffic in between sender and receiver, the acknowledgement 1 is received by late. Before receiving the acknowledgement 1, the timeout is occurred at sender, so that the previous transmission repeated again. After transmitting the previous frame, immediately after some time it receives the acknowledgement for the previous frame, so that it concludes that it is received successfully, so that it set the value to 1. It is ready to transfer next frame 1, and then previously the frame 0 is repeated. Here come to the receiver side. Expected frame is 1 and received frame is 0. Out of order sequence, the frame is received, so that simply the frame is discarded at receiver. Once the frame is discarded at receiver, what is the assumption made by the receiver means the previous acknowledgement may be lost, so that it reissue the previous acknowledgement. So acknowledgement 1 again transmitted. Previous acknowledgement is not lost here, it is reached by late, so that it is accepted. First acknowledgement is accepted, next acknowledgement is a duplicate acknowledgement, so that the duplicate acknowledgement is simply discarded and it transmits the next frame. Frame 1 is transmitted, expected frame is 1, so that receiver is accepting this frame and send the acknowledgement and so on. So in the delayed acknowledgement, this is the case. You can draw your own diagram. First understand the concept, you can draw your own diagram. Right? These are all the things we should remember regarding the stop and wait ARQ. The remaining topics we will see in the next session.